So this formula we've used many times, especially in science. Just converts what? Fahrenheit to Celsius. Well, this one actually doesn't convert Fahrenheit to Celsius. What does this one do? Convert Celsius to Fahrenheit. Yeah. So what you put in is Celsius. What you get out of it, the answer is Fahrenheit. So if you put in Celsius, get an answer in Fahrenheit. But that's going to be the next question. If we have a formula that converts Celsius to Fahrenheit, can we write a formula that does the opposite, converts Fahrenheit to Celsius? So that's what we're going to be looking at. And in general, converting formulas from one to another. Okay. So, for instance, we want to know what is 30 degrees Celsius in our measurements. You know, the rest of the world uses Celsius pretty much, except for North America and one or two other small countries, but most of the world uses Celsius. And if you ever travel, you're going to have to figure it out. Is 30 degrees a hot day? Is that a cold day? Is that, you know, how do you dress or or sweats? 30 degrees for our temperature, that's like cold. But over here, you can kind of see a comparison, though. Like, okay, 30 degrees is right here. That's a little bit below 80. Okay, so that's 30 degrees is pretty comfortable. Kind of temperature right now. But how do you just plug it in? Yeah, plug it in and convert. So we've got 9 fifths times our Celsius, 30. And then you have to add 32. Multiply 9 fifths times 30. Yeah, you can use a calculator, but I urge you not to just go straight to that, because 5 goes into 30 evenly, right? Yeah. So that's 6 times. So 9 times 6. 4. Add 32. That is 86. 86 what? Degrees. Yeah, our answer is Fahrenheit. So yeah, very important to know what we just found. Yeah, so 86 degrees, that's, you know, on that border of good, but maybe a little hot. You're sitting in the sun. And that agrees with what we looked over here. It looks like this is 80, so it's a little bit above 80. All right. Have you guys do the other direction, though? What if I give you the Fahrenheit? Can you find the Celsius? So instead of plugging in for C, you have to plug it in for F, right? So plug 104 in here. And after all last week of solving equations, okay, we're pros at this now. And we can solve. So what would be the first step to solve the equation? Yep. 32. Now that, both sides, right? And show the cancellation. You know, keep everything vertically aligned and neat. 104 minus 32? 72. Alright. Equals 9 fifths C. And we know when we have a fraction coefficient, you have to multiply by the reciprocal. Squeeze it in there, 9 fifths. Oh no, 5 ninths, right? Yeah. The other one, reciprocal. 5 ninths. Even better, because 9 goes into 72 evenly, right? So we've given you some nice numbers that it works out. If it doesn't work out nice, just use a calculator, that's fine. You'll get a decimal or whatever. That's okay. But here, 9 goes into 72 8 times. 8 times 5 is 40. And of course, show that 9 divided by 9 cancels out to 1. 5 divided by 5 cancels out to 1. There we go. So this is 40 degrees. So yeah, a 40-degree day, most of the rest of the world, that's a very hot day. It's a very hot day. 40 degrees. Doesn't sound like a lot to us, but it's a lot pretty much everywhere else. All right, you guys go ahead and do practice the same steps and do the other 3 here. Okay. Check with someone around when you're done just to make sure it's good. All right, so what do we get for 95 degrees Fahrenheit is 35, which makes sense because 104 is 40. So a little bit lower than 104 is 95, and a little bit below 40 is 35. 68 is 20, okay. 50 is 10. There we go. Okay. So on all of these, you saw the same algebra. And we're going back to algebra here. On all of them, we had to first subtract 32 on both sides, and then we had to multiply by 5/9 on both sides. Right? That was a repeated step. So this is what you use to build your formula. And we're starting off all of these. We start off with Fahrenheit. So how do you write a formula that takes Fahrenheit, F, it subtracts 32 from it, and then it multiplies it by 5/9? How could you write that out? How could you write a formula that does that? So take F. The first thing you want to do again is,
I left the white binder here.
you got to subtract 32 from it. And you got to multiply it by 5/9, right? Now, does that work? That's the same 2 steps, right? I subtracted 32, and then I multiplied by 5/9. If you plug in like 105 here, do you get, oh sorry, 104, do you get 40? Go ahead and test that. Test the formula, see if it works. Plug in 104, right? We know the answer that comes out should be 40. Okay, plug in 104 in here, see what you get. Punch it in or write it out, either way. What do you get? Does it come out right? The 40? Yes, no? He has the calculators. Takes 2 seconds. What did you get? Yes? Point. Rounded. 0.0, so is that right? Are we getting the right number? It should be getting 40. So that must mean there's something wrong with this. Now, what would be the first thing to do? If you plugged in 104, what would you do first? What would be the first step after plugging it in? Okay, put a 1 under then. You tell me. This is just pre-algebra. You tell me. What would you punch in to calculate? Five. So you guys did this, right? And so what'd you do first? multiply it by 5/9, right? That's what's right here. Now, what was the step on all of these? So, what was the first step we did here? Subtract 32. So it didn't come out correct because the first step is to subtract 32. So the order of the steps actually matters. We can't just say, well, we need to subtract 32 and then multiply by 5/9 in any order. The order is actually really important, right? So how can we make sure we do the subtract 32 first? What can we add to it to make sure we're subtracting 32 first? Okay. So order of operations, what do you do first? Yeah. What's first in the order of operations? Parentheses. So if I put parentheses around this, then if I plug in 104, I do 104 minus 32, then times 5/9. That's the same thing we did here. 104 minus 32 got the answer, then multiplied by 5/9. So the fact that we have to subtract 32 first, well, lets me know I want to use parentheses, because parentheses always come first in order of operations. Gives you like a priority, what's first, what's second. Okay? Another way of looking at it is just to take the formula as it was originally, and you can subtract 32 on both sides here. And now we don't have a number here, right? So we just leave it as f minus 32 equals 9/5 c. So the 32 cancels out just like in an equation, and still multiply both sides. But you can see, without having parentheses here, it will still be the same problem. So since we're multiplying both sides by 5/9, the way to denote both sides is you put the whole side in parentheses. Otherwise, you're just multiplying f by 5/9, not the whole side. So either way, you can see we get the same. Okay. Two ways of looking at it. You can look at, well, every single one I subtracted 32 and multiplied by 5/9 and build the equation. Okay, I'm going to subtract 32 multiplied by 5/9. Or take the original equation and we can like solve it. This is very similar. Do you guys remember slope-intercept form? And maybe you started in like standard form, something like this. It's very similar to that, where you subtract 2x, divide by something in order to solve for another variable. And we'll be looking more at this tomorrow. Okay. But first, just practice on a few more formulas that you're familiar with. So we know circumference equals 2 times pi times the radius. If this is true, what does r equal? What does r equal? Well, what does it equal using circumference and 2 and pi and everything else, right? So if we know that 2 times pi times the radius equals the circumference, how can we get r by itself? So let me denote this. I'm going to make this red. This is what I'm trying to get by myself. Okay? Let's say if I had something simpler like this. How would I solve this? Yeah, the coefficient of r, what we're trying to cancel out is 4, and that's what you divide by. And it would cancel out. So very similar here, it's just that we have a 2 we're trying to cancel out, as well as the pi. But you can see how they cancel out, they equal 1 in the same way. As long as you do it to both sides, it's perfectly fine. So what does r equal? Circumference divided by pi. Meaning if you give me a circumference and I divide it by 2 times pi, that'll give me the radius of that circle. It's the same thing if I told you, like, if you did this, if I told you, okay, it's 18, and you just plugged it in, the first thing you would do here to solve would be divide both sides by 2 pi, and that would give you your answer. R equals 18. We're just leaving it as circumference as opposed to plugging in an actual number. Circumference could be any number this way. Alright, so go ahead and calculate this. What is 18 divided by 2 pi? And remember, pi is approximately 3.14. So our answer is going to be r is approximately And you can always estimate, let's see here, 2, let's say I round this to 3. 2 times 3 is 6. 18 divided by 6 is 3. So the answer is around 3 somewhere. Yeah, you can estimate. So go ahead and punch it in. Obviously, you do need a calculator for this. You can't round it off. Without it, you will not have the correct answer. And let's round to the nearest hundredth. Since our pi we're using is 0.14, that's where we're going to round to as well. So punch it in, see what you get. 18 divided by 2. Now, some of your calculators might have a pi button. You can use that, or you can use 3.14. But if you have a pi button, just use the button that says pi. No, that can't be it. Then the answer is going to be around 3, right? It doesn't matter. You put it in wrong then.
Yeah, I got 9.
No, we already checked it, right? 2 times 3 is 6. 18 divided by 6 is 3. So it's around 3. So check your format. Maybe you put it in wrong. Hey, you got to be careful how you put things in. So, what is it? 2.88. Okay. 2.88 inches, right? Yeah, there you go. That's what you should be getting. Now, if you got something that's way too big or that's way off from this, maybe you use your calculator wrong. I'd urge you to do it this way. Do 18, which is times 3.14. You have to do the bottom first, right? You can't do 18 divided by 2 and then multiply it by 3.14, right? That's not what that says. So some of you might have done this. You typed in 18 divided by 2, and you got an answer of 9, and then you said 9 times 3.14, but it doesn't say times 3.14. You get to divide by 3.4. You're dividing by 5. So instead, do 18, right? 18 divided by 6.28. And see what you get. Yeah.
It was 2.86.
2.86. All right, 8886, close. So this should give you the correct answers. But you can see how the rounding estimation, right? That rounding estimation is absolutely imperative. Because if you said that the answer is 28, that's the calculator talking, not your brain. You've got to be thinking. 2 times 3 is 6. 18 divided by 6 is 3. You get anything else that's way off from that, you can't just say, oh, calculator said. That means you put something in incorrectly. Calculator is only as smart as the person using it. It's not going to do everything perfectly. Okay? Keep that in mind. It's not the easy way out. For now, I don't have to think or do any thinking anymore. It's if I put something wrong in the calculator, it's not going to work. Okay. Let's practice 2 more. So that was what? Circumference, radius. Let's look at area. You can stay after class. I'll talk to you. So we know area of a triangle, right? Area of a triangle. Area is 1/2 base times height. Why is it 1/2? Why is it 1/2? Well, what's base times height? What's that area? Area equals base times height. What was that the area of? Just had base times height without the 1/2. Cool. 7th grade. Oh, what? Well, this is an area of any triangle. Of all triangles is this. Do you remember what base times height is? Good to know. It's the rectangle. Area rectangle. Space times height. Right? Base times height. That gives you how much space it takes up. Probably count squares, things like that. Well, triangle is just really half a rectangle. So that's why it's, if I just kind of make the same side here, go over here, and this same side right here, you have a rectangle or a square, and the area of that is exactly, this triangle is exactly half of the whole rectangle. That's why it's half. But let's say I'm given a height and a base. There should be a base, h, b. Right? And I just want a formula to plug it into. So let's say if I just plugged in here, 1/2, let's see, 20 equals 1/2, 5, we're solving for h anyway. There we go. We want, oh yeah, that's right, 5, and then times h. So how do we solve this? How would we get this by itself? You could do divide both sides by 5. Right? 4 equals 1/2 of h. And then multiply both sides by 2. A equals h. So if I want to do it in general, without picking a certain number, without picking certain numbers like 20 and 5, I can follow the exact same steps. Base times height. So over here I divided both sides by 5, so it canceled out. So over here I can divide both sides by b. Still cancels out in the same way. Okay. On the left side I did 20 divided by 5 is 4, but here I can't simplify area divided by base, so that's when you just leave it. Area of base equals 1/2 b. Here I multiplied by the reciprocal on both sides. 1/2 is 2 over 1. 2 over 1. Cancels out, just like we did over here. Cancels out. Well, it should be h, but canceled out the h. So now I have 2a over 1b equals my height. And if you try it again with 20 and 5, yeah, 2 times 20 divided by 5. 2 times 20 is 40. 40 divided by 5 is 8. So we get the same answer no matter what. And of course, include units. Whenever they give you units, you gotta have units on those answers. So if you get stuck at first without the variables, with the variables, try it without. Try it with just regular numbers. It might make it a lot easier. Okay. I'm going to leave you with that. You guys have your homework, which is this.